Okay, so this is a particular notation you need to be aware of. It's not as scary as it looks. As anyone, I promise I won't ask you to explain it unless you want to, but just raise your hand in the air if you've sort of seen that notation before. I bet more of you have than you think. Think statistics. You might have come across it in statistics or spreadsheets. Yeah, you've seen it? Okay. Anyone else? Okay. So I'll give you the fancy name for it. Might even just change the language here a bit. And that's what it means. So sigma notation uses a capital sigma from the Greek alphabet, and it's a shorthand notation for describing the rule of a sum. So this basically means sum from I equals 1 to n. That's how to read it. Sum from I equals 1 to n, and this will be, it's not how I've got it written here, but this will be the rule for generating the sum. Sum from I equals 1 to n, this rule. Now, number one, it's a notation that you just need to be familiar with because we come across it a fair bit. Number two, it's more powerful than the SN notation because it wraps everything up into one neat little package. Not all sums have to start from 1. This one does. N would actually usually be a number, but doesn't have to be. Could be an expression. And then the rule is packed into the sum notation as well. I'm going to show you a simple example in a second. Okay, we good with that so far? It's just notation, team. So, this is an example. This is the sum from I equals 1 to n, and the rule is 2i. So what we do is an iterative process. That means we repeat the same process over and over again by increasing I by 1 each time. So when I equals 1, this would be 2 times 1, which is 2. When I equals 2, that would be 2 times 2, which is equal to 4. When I equals 3, that would be 2 times 3, which is equal to 6. And we repeat that up until n. So that would be up until 2n. Always means sum. A difference could be made by just having a negative 2i. That would make negative 2 minus 4 minus 6 minus 8, etc. And so on. Does that make sense so far? It's built in. Yeah, that iterative process is built in. Good question, Eve. You can't easily. I don't think. No, it's just not part of the notation to assume that I goes up by a different jump each time. It's always jumping up by 1, by a whole number. Okay, so you actually have to manage what's happening with the operations around the rule if you wanted to have it jumping up by something. Okay, so if I go the sum, this is just really specific examples now of I equals 5, sorry, I equals 1 to 5 of 2i, and that would be 2 plus 4 plus 6 plus 8 plus 10. And that would be 6, 12, 20, that would be 30, I think. Does that make sense? I just added them up in my head. I think I added them up, right? Nothing special there. Okay, so you can see that this would be the equivalent of saying Sn is equal to 2n, isn't it really? It's the equivalent, but it's all built into it. And what I don't have room for on this page, but I might try and come up with another example, I don't have to start off with I equals 1. So we could say I equals 10, for example. And then obviously n would have to be larger than that. Okay, a couple of things. For a constant k. So when I say constant, I mean that it's just a number like 6 or pi. It's just a number. The number doesn't change. There's no variables involved. For a constant k, if I summed up k from 1 to n, then when I equals 1, the term would be k. When I equals 2, the term would be k. When I equals 3, the term would be k, and so on. So I would be adding up all of these k's n times, yeah? And that's why we've got kn there, because we know that multiplication is just a summary of repeated addition, right? So if I had, I'll just do an actual example down here. If I had the sum from I equals 1 to 5 of 6, that would be 6 plus 6 plus 6 plus 6 plus 6, which would be 5 times 6. Oh, it's 30 again. I'm not meaning to be 30-centric this lesson, but there you go. Is that making sense? Okay. Can I go to the next screen? I normally write 4 screens at once, so it's a bit tricky. Okay, what do you think? These are 2 more results or productions, I suppose. N, I goes from 1 to k, so 1 to n of kai. So k is a constant and ai is the rule generated. What's going to happen when I sum that out? Well, I'm going to have k, sorry about the a instead of the u. I should change it, but I won't because it doesn't really matter. K times a1 plus k times a2 plus k times a3 all the way to k times an, right? So we're going to have a common factor of k there, okay? Now, I hope this is not too much of a bigger jump. I'm mainly doing this jump because I don't have room to put in the middle step here, but I'll go back and say it if you need me to. So that means that I can put k outside the sum symbol. My k's are evolving into b's by mistake. Hang on. I'm not meaning them to. Just being squishy. Does that make sense? It's basically common factor knowledge here. So if you're given a sum and there's a constant involved, then you can factorize out the constant effectively and just deal with a simpler sum. I don't think I have, I've then got textbook after that. So I might just come up with a couple of examples in a second for that. And similarly, if I've got 2 different sequences, So AI plus sum to AI and the sum of BIs. Well, then if I sum them separately, like if I color code it, I'm going to have A1 plus A2 plus dot 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 all the way up to AN. And then I'm going to have plus B1 plus B2 plus all the way to Bn. And that's going to be A1 plus B1 plus A2 plus B2 plus all the way to AN plus BN. So what I've done, I've just reordered those two sums. Haven't finished, but is that okay so far? Well, that's just a sum of these two things added together. So I can say that the sum to n from I equals 1 of AI plus BI. So it's basically a shorthand for saying if I've got two sequences that are added up over n terms, then if I want to add those, sums, if I want to add those sums together, I can sum up all the two individual terms and then I'm kind of good to go. Okay, I'm just going to erase the bottom now so that I can give you an example of the top there. It'll come back. So, e.g., if I had the sum from I equals 1 to 3 of 5, 5i plus 10, then I could make the sum from 3 to I equals 1 of 5 outside of I plus 2. And so I can take out the common factor of 5 out there and then just sum the simpler sequence of I plus 2. So that would be 5 outside of 1 plus 2, 3, 2 plus 2, 4, 3 plus 2, 5. That would be 5 multiplied by 5, 8, 12, which is equal to 60, which is 2 times 30. So I'm really pleased that I'm keeping with my 30 theme today entirely by mistake. Compare that to, don't have to write this down. I'll do it in blue so you can see, you don't have to write this down. Compare that, it's not that hard, but compare that to generating this sequence, which would be 5 plus 10, which is 15, 5 twos are 10, plus 10 is 20, plus 5 threes are 15, plus 10 is 25. Like I said, it's not that hard. It does get us the same sequence, but we're generating bigger numbers. And I hope if you can imagine if it was more complex, like imagine that was pi instead of 5, something like that, like pi I plus 2 pi, then taking out a common factor may simplify some operations in between. Okay, is that making sense? Any questions? Yep. Okay. And I'll do the example above this time. Example, if I had the sum from 5 to 1 of 2y, and I added it to the sum from I equals 1 of 3i, I can simply make that equal to the sum from I equals 1 of 5i, 2i plus 3i is 5i, and then generate that sequence, and away I go. And of course, if it was, I'm using small numbers because they're easy to do in your head. But you could definitely, if I said it was the sum from 1 to 100, then you could definitely use the series formula, right? Because this is definitely an arithmetic sequence. It's an arithmetic sequence with common difference of 5. You can work out what U1 is, and you can work out what U100 is fairly easily from this. That's fine. So you could then use the sum formula. If it was 1 to 100, you could use the sum formula to work it out. And again, if this was the sum from 1 to 100, and this was the sum from 1 to 100, could you, if you could imagine, you'd have to use the sum formula once here to get a number, use the sum formula once here to get a second number, and then add them together to work out the final answer, right? As opposed to this, which in one step gives me one sum or series, and then I can just use the series formula once. So unfortunately, my simple examples, in a way, are disguising the fact there's some pretty tricky stuff going on. 5 plus 10 plus 15 plus 20 plus 25, which we can probably do in our head rather than using the sum formula. So 15, 30, 50, and finally I've got something which is not divisible by 30. Did I make a mistake? Yeah. But you can split it though, Eve. It's a really good question. So what would happen if I had, say, for example, the sum from 1 to 5 and I had the sum from 1 to 7, right? So this is a little bit more than I wanted to go through, but it's definitely a good question. What I could do, I'll just duplicate this and then sorry. Excuse me. So if I had the sum of 5 of 2i and the sum to 7 of 3i, I could say that's the sum from 5 of 2i plus the sum from to 5 of 3i plus the sum to 7 of 3i from I equals 6. See what I did there? So then I can go, these first two here, I'll color code it so we can sort of see what we're doing. So these first two here would become the sum from 5, the sum to 5 from 1 of 5i plus, and then I'll just generate it. I'll just go 3 times 6 is 18. Oops. Plus 7 times 3 is 21. So 3 times 7. And then I can go from there, if that kind of makes sense. So you can make it match up to do the most of the processing work and then just deal with the leftovers like I've got there. And there you can start to see some of how the notation can be a little bit more powerful because you can then split with a starting number starting from other than 1, which is impossible to do with simply with series notation, SN. Okay, thanks, Steve. I really appreciate that question. It really uncovered some thinking there. Anyone else got any questions? This video will go up on Google Classroom. I can put the notes up too if people want me to. Just need to ask. Okay, so let's have a look at the textbook. Page 125 summarizes this. I haven't quite got this organized on my laptop, sorry, but I'll be there in a sec. Okay, so we'll go to page 125. Oops. They've used different. They've used slightly different notation, I think, but it's the same deal, really. They've got sigma as I've got it. They've used k instead of I, which is fine. So you can see here they've got from k equals 1 to n, ak plus bk equals, you can split them up. So they've gone the other way around. And instead of using k as a constant like I did, they've got c as a constant because they were using k for the iteration. So the sum of c times ak, you can bring the c outside the bracket, outside the sigma symbol, like so. And finally, if c is by itself, then it'll just be cn, just like I told you about before. So that's the summary. Oops, oopsies. Let me just do that. They've got a little bit more here, including an example if you want to see it for the sigma notation. They've got an example here too of the sigma. They've got fairly simple examples like mine, but they aren't always arithmetic sequences. So they've a series, sorry. So they've done that just so you can sort of see it in action there. That's page 124, 125. I haven't tried to use sigma notation on my calculator, so I won't go through that now. There is a link there to graphics calculator instructions if you want to follow it. I hope everyone's got their calculator set up properly as well, by the way. Okay, so what I want you to do is on the page after that is exercise 5G. I think it's the next page. So question 5, I'll just go back to it. So 5G it's a few pages, I'm sorry, is on page 128. Question 5 asks you to evaluate the arithmetic series from sigma notation. So I want you to do that. And then after you've done that, question 8 onwards, I said on my notes here question 9. So question 8 or 9, start there. Yeah, question 8 is probably fairly straightforward. So question 9 onwards just had some word problems with it that can be solved best using arithmetic series. So have a go at doing as many as you can in the next 10 minutes or so. Practice them between now and the revision lesson on Friday. So do as many as you can before Friday, and then in the revision lesson, I'll cover off on some more. Just cover off on the whole course and give you some revision work to do as well. Okay, I'll stop the video.